Hi, my name is Erin Tharp, and I did my presentation on alcoholic fermentation. In this presentation, I'm going to be speaking about the process of alcoholic fermentation and the different ways that it is used in our world today. So let's get into it. My perspective on alcoholic fermentation. I believe that alcoholic fermentation is an important process because we are able to produce energy under anaerobic conditions. By anaerobic, I mean living or occurring only in the absence of free oxygen. It is also used by many humans in things such as alcoholic drinks, ethanol fuel, and bread production. So in this image, it shows that lactic acid fermentation can produce things such as soy sauce, cheese, and yogurt. And to just give a little bit of background so we're able to understand the difference between alcoholic fermentation and lactic acid fermentation. Lactic acid fermentation is a metabolic process by which glucose and other 6-carbon sugars are converted into cellular energy and metabolite lactate, I think that's how you say it, which is lactic acid in solution. And essentially, this occurs in some yeasts and also animals, such as humans. When we exercise, a lot of the times lactic acid fermentation is being built up, and a lot of the time that's when they say you need to warm down and stuff, so that lactic acid fermentation cannot form. But in this presentation, we're mainly going to be speaking about alcoholic fermentation, where we can produce things such as beer through ethanol and CO2, wine from ethanol, and bread from carbon dioxide. So now let's get into alcoholic fermentation. It is also known as ethanol fermentation, and it occurs in yeast and some bacteria. It is an anaerobic process, like I said before, where the yeast converts simple sugars into 2-ethanol and carbon dioxide. As you can see from the image here, sugar plus yeast without oxygen, anaerobic, equals carbon dioxide and alcohol. So the process, essentially, alcoholic fermentation is the sum of glycolysis and then fermentation, and once both processes have occurred, we are able to have alcoholic fermentation. So I'm going to give a little bit of background first on the whole process, and then I will individually explain glycolysis, and after that I will explain fermentation, and we'll have the whole process finished. So the process, glucose is firstly converted into 2 molecules of pyruvate. Then the pyruvate is converted into acetaldehyde, which is carbon dioxide, is then released in this reaction. And after that, the acetaldehyde is then converted into ethanol, and you have alcoholic fermentation. So now on to glycolysis individually. It begins with each glucose molecule being broken down into 2 pyruvate molecules. The glucose is then broken down into a 3-carbon sugar. And during this process, we are able to produce a net energy of 2 ATP and 2 NADH molecules, which will bring us to fermentation. Because once that energy is produced, we're able to pass that on to the fermentation process. So now, after glycolysis, we have fermentation, as I said before. And during fermentation, a carboxyl group is removed from pyruvate, the pyruvate that we formed, and this releases carbon dioxide, and it produces the acetaldehyde that I was speaking about in the first slide. And then after acetaldehyde is produced, the NADH that we produced in the glycolysis portion passes electrons to the acetaldehyde molecules, and it regenerates NAD+ and finally forms ethanol. So that was a lot. So we have a picture here just explaining the whole process And in this picture, we can see that the whole process really clearly moves throughout the top through glycolysis and then down to fermentation. And to start, we see that the glucose is first converted into 2-pyruvate, releasing its carboxyl group as carbon dioxide, as you can see on the right corner of the image. And this then produces a 2-carbon molecule of acetaldehyde on the bottom right. And then after this, the NADH passes its electrons to acetaldehyde, as you can see on the bottom. And then the NAD plus molecules are regenerated, and after that, ethanol is formed. And by the NAD plus molecules being regenerated, the process is able to continue on and on again. And so I hope this part made sense, and now we're going to get into how it is used today. Okay, so this process is actually used in day-to-day life for food and beverages. As I was saying in the beginning of the presentation, it is used in food to produce things such as breads, and then in beverages to produce things such as wines, beer, and gin and vodka. So when producing wine, the yeast turns the sugars from fruit juices into ethanol. And in the production of beer, from producing grains, we are able to have alcohol from the ethanol production. And then lastly, potatoes can be fermented and distilled, producing gin and vodka. So next, through alcoholic fermentation, we are able to make bread. This is done when the sugars, yeast, flour, and water are combined together to form a dough. And then after the dough is formed, the yeast breaks down the sugars and releases carbon dioxide. And then this is what causes the bread to actually rise in a process called proofing. So as you can see in the image at the bottom right, you have the not proofed bread and then the proofed bread that's been let sit for about 2.5 hours. And through proofing, the yeast ferments the dough and produces gases, and this then leavens the dough and makes it rise. These are both examples of how alcoholic fermentation is used to produce food and beverages. So next, we're going to speak about how alcoholic fermentation can actually be used to produce ethanol fuel. Ethanol is a domestically produced alternative fuel that is most commonly made from corn. Because of the vast available lands in the Midwest, that is mainly where ethanol fuel is produced, because they have so much free land to grow the corn, and they're able to also have the ethanol plants there, and it just makes it a really easy process with the amount of available lands that are in the Midwest. So as you can see from this image, the process is done by the corn being grown. Then it is taken to the ethanol plant, where the ethanol is produced through alcoholic fermentation. And once the ethanol is produced, the ethanol fuel is taken to the gas stations, where people are able to fill up their cars. And when they drive their vehicles, their cars release CO2. And that carbon dioxide is then brought up into the atmosphere, and it is used by the corn to grow. So the process can really continue over and over again, and it becomes a feedback loop. The one issue with ethanol fuel is that it must be delivered through a pipeline, and these pipelines need to be new and clean every single time because of ethanol's affinity to water and other solvents. So it makes it really difficult to bring the ethanol fuel to places around the country. But even though this is a big downside, the average price in the US in 2009 for ethanol gas was only $1.79 a gallon, which is pretty reasonable for a gasoline that produces 35% less greenhouse gas emissions than the gasoline that we currently use does. So I think it really weighs out the negatives by being able to produce so many less greenhouse gases from this, and it really makes it a more positive, because a lot of the times nowadays we're looking at having electric vehicles and things like that, where if we just try to reduce our greenhouse gases by using things such as ethanol fuel, we can still have the comforts of using the vehicles that we have now available, but in a different way by producing ethanol fuel. So lastly, in this presentation, we are going to look at the future of ethanol fermentation. Amritz is an American company of science and technology. They are actually the leader of research, development, and production of pure sustainable ingredients for health and wellness. And they're also a very large producer of ethanol fuel. A quote from them that I thought really summed up their fuel production perfectly stated that we are producing the perfect renewable fuel, a fuel that eliminates the obstacles plaguing current biofuels while still enabling dramatic reduction in greenhouse gas and tail pipeline emissions. Ethanol fuel is showing the future of alcoholic fermentation, a way to continue to fuel our vehicles, but in a more environmentally friendly way. I also found that people are using alcoholic fermentation to 3D print yeast, which is something that I'd never heard of before. These 3D printed yeast can be placed in fruit juices, and then they will produce alcohol. If this becomes a well-known popular phenomenon, it would stop the need for batch production of alcoholic beverages, because people could make them in their own homes. If this was done, this would drastically change alcohol production and the market for alcohol in general. And I thought this was really interesting because I'd never heard of anything being done like this before. So I think it would really kind of change how we view alcohol and going to the store and purchasing it if this could be done in the near future. So thank you. I hope you were able to learn something about the process of alcoholic fermentation, what it is used for, and the future of ethanol production in general. And here are my references.